All right, so then for example 9, what we're going to do here is we are going to sketch a graph of a function, and we're going to start off by looking at our leading coefficient, or using our leading coefficient test. So we're going to look at what our y is doing as it approaches x from the left. So on the left side of the graph. Then we're going to look at our y values are doing as x approaches positive infinity. So that means as it's going to the right. So if you look at your leading coefficient, you have a 3, but your degree is a 4. So since you have an even degree, that means your y's are either both going up or they're both going to be going down. Since your 3 is positive, that means they're both going to be going up. So both of your y values should be, or your end behavior should be going up. Now the second thing we need to do is find some zeros. So if we take our function, 3x to the 4th minus 4x to the 3rd, and set it equals 0, we'll try to factor this so we can take out an x to the 3rd, which equals, sorry, I'm getting ahead of myself, x to the 3rd, which leaves you with a 3x minus 4 equals 0. So we set x to the 3rd equals 0. Well, we're just going to get x equals 0. In this case, you're going to have a multiplicity of 3 because we have an x to the 3rd. What that means, it doesn't mean you have 3x equals 0. Well, it does mean you have 3x equals 0s, but in terms of multiplicities, that means your graph is actually going to go through your graph at x equals 0. So it's going to intersect it somehow. Our other 0, we had to take 3x minus 4 is equal to 0. Add 4 to both sides. Divided by 3, you get a 4/3, also known as a 1.3. So if we go over 1.3, we put a dot. Now this has a multiplicity of 1, which means your graph's going to be going through there also. So what we should do is we should find some other points and put them on a table. So if we make a table of values, we're going to have an x and we're going to have an f of x. We need to make sure we include our actual zeros we found. So if we make a table and say we start at -2, -1, well, if we plug a 0 in, we know we're going to have a 0. Then you have a 1, a 4/3, or a 1.3, which is going to be a 0. And then we'll try a 2, and we'll plug in a 3. So if you plug these values into your function up here, well, when you plug in a -2, you're going to get an 80. That'll be a little difficult to graph. Plug in a -1, you get a 7, and then we have a 0, 0. Plug in a 1, you get a -1. 4/3, you get a 0. Plug in a 2, you get a 16. Plug in a 3, you get a 135. So let's plot the points we can. Well, we can go back 1, up 7. And if you go back 2, up 80, that's way up there. Here is your 0, 0. Over 1, down 1. Here is your 1.30. Over 2, up 16, way up there. Over 3, up 135. So this graph comes down like so, and it looks a little bit like a parabola. Now remember, don't cross over your 2 because that's a 2/16. So don't just slop down something. So that would be your graph of your polynomial. And look at our end behaviors. Those are following what we got from our leading coefficient test. So that is how you graph an even function.